Signal Sciences secures the most important web applications, APIs, and microservices of the world's leading companies, protecting over 7,500 applications and 150 billion production requests per week. Signal Sciences Next-Gen WAF and RASP help companies increase security and maintain site reliability without sacrificing velocity, all at the lowest total cost of ownership. Signal Sciences patented technology protects any application against any attack with integrations into any DevOps toolchain. Signal Sciences, demand more from your WAF. Learn more at securityweekly.com/Signal Sciences. As the world of software-driven everything becomes a reality and development cycles speed up, sales teams are taking a new approach to application security, one that enables security teams to scale by empowering developers to integrate security into their development workflows and toolsets, all while giving security teams the visibility and control they need. Snyk helps software-driven businesses develop fast and stay secure with a developer-first solution that seamlessly and proactively finds and fixes vulnerabilities in open-source libraries and containers. Learn more and see the solution for yourself at securityweekly.com/Snyk.
Welcome back to Application Security Weekly. I'm your host, Mike Shima, joined by Matt Alderman and John Kinsella. We are looking for high-quality guest suggestions for our Enterprise Security Weekly podcast to fill our upcoming recording schedule. We're committed to educating and providing entertainment for the InfoSec community, and we would love to hear from you about who you would like us to interview on the show. Submit your suggestions for guests by visiting securityweekly.com/guests and submitting the form. We review suggestions monthly and will reach out to you once reviewed. Join us at InfoSec World 2020, June 22nd to 24th, now at Disney's Coronado Springs Resort. Security Weekly listeners save 15% off the InfoSec World Main Conference or World Pass. Visit securityweekly.com/ISW2020. Click the register button to register with our discount code or the schedule button to sponsor a micro interview. And this brings us to an interesting week of a mix of articles I brought out. This time I wanted to highlight two interesting vulns. One is JWT, or the JWT, or JSON Web Tokens. And in this case, there is effectively a authentication bypass by playing with the case sensitive, or taking advantage of a case sensitive filter that shouldn't have been. Basically, if you're not familiar with JWTs, they have the ability to what's called like algorithm agility for encryption. Basically meaning you can set an encryption algorithm to none, which, as it says, is no encryption, no signature validation on this particular token. So this alg none was restricted. It was basically filtered out to be rejected by this filter, except that is only if it was only looking at all lowercase alg : space none. If you drop an uppercase letter in none anywhere, NONE, for example, you bypass the filter and you now have essentially a authentication bypass issue. So this is a pretty interesting vulnerability, I thought, just for how simple it was, and of course its correspondingly huge impact.
Yeah, talk about input validation, huh?
Yeah.
I got scared when I saw this one at first. Like, I see vulnerability in JWT, I'm like, oh no, this could be bad. But luckily it's not too bad. But what was interesting about to me is this is a good example. It's sort of hard probably to catch doing either. I mean, you might catch it in a code review. You might catch it from a static analysis. But this is where, this guy, I believe this guy, found it originally through using Burp Suite, everyone's favorite tool. And so that was sort of, I thought, sort of cool about this, that like, this is where, pretty good example where you need to do dynamic testing, either internal or external.
Yeah, and especially that angle of testing, it's really easy to set up some tests and just say, hey, alg none, is that rejected? They say, yeah, cool, it's rejected. But as you pointed out, this is not necessarily even a new or unknown type of flaw. And that Burp Suite plugin that he was using actually has a whole suite of different scenarios and test scenarios. And that's where the robustness of your tests really come to highlight how effective your security is, for sure.
Yeah, that's why I was curious in our previous segment with Rebecca about, when you look at, if you do everything up front in a threat model and you get fewer and fewer results out of your tools, then my question to her was, well, do you get rid of some of these tools? But what you see here is the robustness of a test completely missing a vulnerability here, a pretty substantial one, right? And so I think also what it potentially allows organizations to do, if they're doing their threat models right, is allow those tools to be a little more robust in their tests, maybe, to look for those corner cases like this that I can now address and fix back in my code.
Yeah, and that's the other reason I wanted to highlight this, is that it has two fundamental input validation issues or input handling issues of being case insensitive when you're filtering. So be careful with those regexes, and always normalizing data before you apply the security check. So in this case, especially with headers too, and HTTP 1 is a little bit vague about the case sensitivity or the overlap of competing headers, and that's where we saw, speaking of Burp Suite again, Portsweaker at the beginning, I can't even remember what year we're in, but I think beginning of 2019, HTTP request smuggling. That was a lot of taking advantage of overlapping types of headers, if you will. And this is just another case of doing that normalization of what headers are coming in, what's the case sensitivity of those headers, normalize them, then apply those input validation checks. And as you were just saying, Matt, this is that type of scenario that if your test missed it, and now the pen test or this tooling has found it, that is a great way to go back, use that feedback loop, modify your threat modeling, modify some of those questions that you're posing to developers, and just make sure they're building their tests in a more robust way to be able to catch these types of issues.
Yeah, because this is a perfect test now that you want to perform as part of a regression test. Just like our authentication was always true bug that we had in our own software, right? This is a very similar case where you just run it through different cases and just make sure it doesn't show back up and regress back as part of changes. So this would be part of your interactive testing side that also has to get updated here.
Yeah, I did add. Go ahead.
Sorry, the other interesting thing here that I was curious about, JWT Auth is one of those things which, as a developer, we almost, at least I've never written it. I go grab the library for this whenever I can, and my teams do. So one of the questions in my mind is this something that Auth0 wrote, or are they taking someone's library? So in other words, does this one exist out a little bit wider, or was this just their own?
Yeah, and I believe that I think in the article it links to yet another article from Auth0 talking about specifically this alg-none in other software that they had come across. So there is a bit of
down the rabbit hole.
Yeah, there's definitely a lot of clicks to follow here. Links. I'm not sure what kind of word I just made up there. But one of the things I also want to highlight about this, we won't go too deep in the weeds, is that kind of fundamentally, I'm a little bit of JWT is sort of a just won't think about using it. If you want, is sort of what I see it standing for, because it makes me a little bit worried. Both through this alg-none, it's a completely stateless type of session management mechanism, so it's really hard to revoke. And there are some other gotchas with it. And I did include a link to Pasado, which is sort of a alternative to JWT, which tries to address a lot of those what are called like foot gun mistakes that can be made. And basically, they say rather than give all of this algorithm agility for all these different types of encryption algorithms, all these crypto choices you can make, just here's what choices have been made for you, and these choices are much more default secure. And it also has a little bit of nuance in the implementation around mistakes that can be made around reusing nonces, making sure that you actually have decent pseudo-random number generators rather than just rolling a D4 and taking the result. And so I just want to encourage that is when we're talking about threat modeling too, and that trying to strive to starve out a technology, or perhaps more nicely stated, address a class of vulnerabilities, JWT does introduce kind of a class of vulns, and something like Pasado starts to address that and makes it a lot harder to have these sorts of mistakes. So with that, though, let's move on to our next flaw. And this one was really fun. Again, for some really interesting details. So Ruby gems. So we've heard about typo squatting. We've probably all are very familiar by now in 2020 that malicious actors out there are putting up typos into Node.js, into Ruby gems, into Python for that matter. I think even Go has had some documented examples of this. Basically, if you're pulling down a dependency and someone mistypes a L for an I or uppercase for lowercase, there are potentially malicious dependencies you're pulling in. What was really neat about this particular scenario is that the Ruby gems, the repo, actually knows about typo squatting. And so what they did was they introduced a tool that measures Levenshtein distance, which essentially says, is this really close to, like, how many substitutions or typos is this one word close to another word, just to try to detect these types of issues. What's really clever here is that the attackers, rather than going after the typo, went after the swapping a dash for an underscore or vice versa. And that, of course, has no bearing on the Levenshtein distance. And that, to me, was what really stood out in here about attackers really being smart about what controls are in place and how can we still bypass those assumptions.
Yeah, I thought this was interesting because it was a dash swap for an underscore. Because I think the underscore was the original in the library, and they put in a dash. And the dependency tree here is actually very big. I couldn't count how many actual files, but it was in the hundreds. I just kept scrolling there for a long time, all with that replacement. All the dash replaced the underscore, and boom, now you have a whole malicious set of dependency libraries that can now get included into your build.
Yeah, so really, again, it just drives home that if you don't have any story, or if software composition analysis and dependencies isn't part of your threat model just at the very beginning, you're going to be prone to this because developers may make mistakes, and it's going to be really hard to detect because even as you were saying, Matt, just scrolling down through a couple hundred of these, if I were doing the same thing and trying to put my security eyeballs on to catch which one of these are the malicious one and which aren't, I'm not going to really notice that dash or underscore for sure.
No, and I'm curious, would software composition analysis tools actually pick these up, or does something like the integration with Reversing Labs, who actually did the malware analysis on the files, need to be pulled in here to look for those hashes of the files? I'm just curious. I haven't attempted like a name swap like that before. I don't know how the SCA tools handled that analysis.
It seems like you could have a, sort of top 100 libraries or something. And then if you see someone, I could see possibly doing something sort of like what Ruby Gems is doing, but on the static side. But yeah, I don't know. On this one, I've always sort of wondered, it'd be nice to see the repositories go to a little more effort. And I didn't realize that Ruby was doing that, the checking that they're doing. So that's at least a good start. Yeah, it's cat and mouse. There's always going to be someone trying a little bit better. It's I wasn't fully clear from the blog post with my 30-second browse of it, if their product is just purely doing the malware analysis or if they're trying to capture this type of naming convention as well.
No, I mean, Reversing Labs is just doing the malware analysis, and then they're going to add them to the blacklist for the lookups, right? But who's actually, like I said, from a software composition analysis, are the tools actually doing some of that same detection from a malware perspective that Reversing Labs is doing so that they can do this? Or do you need a combination of the two to effectively look for this type of replacement?
Yeah, and I'm going to guess there's definitely a chicken and egg here, because you could sort of do and I'll do the jazz hands, machine learning to say, here is the outlier that the more underscore donuts gem is the one that, how come only a few people are using this one? And the more dash donuts gem is the one that everybody else is using or is, pervasive throughout the rest of your apps. So you can look at that from the outlier perspective, but the SCA is going to tell you what you have. But until it knows that this actually, the more underscore donuts gem is the one that's the vulnerable one because it's been Trojaned or otherwise malicious, it's just going to say, yep, you've got it. You're on the latest version, and continue on.
Yeah, away you go.
Yeah. So speaking of continuing on, I do have one article here that possibly reminds us of the obvious. Yes, exactly. Docker image put onto the internet and compromised. Maybe
shocker.
not necessarily. Yeah, shocker. I did like that. It's at least a nice write-up. It's a nice description of what can happen. There is a little bit of aspect is that it was definitely attempted to be put up there, not so much as a very obvious and see, hey, and drive home the point that yes, you put something vulnerable out there, it's going to be compromised. But I guess two things: one, how quickly it could be, and how easy it is to find these within all of these registries. So I guess I'll just say real quick on the speed of compromise, that I'm going to say just speaks more to what's your patching strategy and what's your reaction strategy to be able to respond to, say that there is a 0-day, but more important, just say there is now a vulnerability in your Ruby gems that you need to patch. How quickly would you be able to patch them? And could you do that within a 24-hour period, or is it going to take you longer to do so?
Yeah, and the scary part about this is there are a lot of containers that are running as root in repositories all over the place. I think Nginx runs as root by default, right? And I know Paul had to go through a lot of configuration changes to get it running out of root. This is highly common. And when you think about kind of what he walks through and the impact of this, there are a lot of container images out there that are vulnerable to attacks because a lot of them are running at root privileges.
Absolutely.
No root.
I think maybe no root. And that's probably got to be that aspect if you're running if that root is in your container and that's not part of your threat model that you're trying to address, have that conversation with your dev team and have that conversation with the AppSec team, so you're figuring how to do the Alderman rule for your threat model.
And be rule number 1, maybe 0.
Yeah.
We had it in the CSA continuous doc. That one didn't exist. So I fully agree that it's something that should be out there, should be used. Looks like the video's breaking up now. Yeah, I hear every time Matt says it, but he is spot on when he says it.
That's true. And one of the things, I guess that you mentioned CSA. Go ahead.
If I'm nothing, I'm consistent.
Oh, you're more than that.
That's right. So it can't be rule 0. It has to be at least rule 1, because otherwise it'd be nothing. But John, you did make a good point about referencing the CSA, and that was one of the things. Is a quick callback to our discussion with Rebecca. We were talking about like standards, and there's some better standards for application security, like the ASVS from OWASP. That's a good reference because it's very much of here are things to do, and here are ways to build stronger architectures, rather than something like the OWASP Top 10 that says don't do this or make sure you aren't vulnerable to these types of flaws. And you mentioned there the CSA has a good checklist around cloud environments, around containers. Would be another standard to align with, and that's sort of where you would start to build your threat model, and even better, if you can build a Terraform that enforces this by default, that would be a even bigger win for your development team.
Yeah, it gave me a few moments of pause when Rebecca was diving so heavily into talking about Terraforms and things like that to automate that process. I think it's actually a really good thing when you can do it down that path. But I think historically, when I've thought about threat modeling, I think more of the more it's a bad thing, but the magical side, right? Imagine what your attacker is, and then start thinking from their point of view. So I'm looking at it more from almost an art, where she's taking it to a science, which I think is the way it should be. So yeah, we've got 7 different threat models here to choose from and see which one's your favorite. Which one's your favorite so far, Mike?
Yeah, so we're looking at this CSO Online article, and honestly, I do like the NIST one because it really boils down to those: what are you building? What could go wrong? What are you going to do about it? And that metrics question: how did you do? Because it also is starting from very simple to generalize, and you can generalize just to say, characterize what you're building and what's being targeted. Are you targeting a system? Are you targeting an application? And I like that aspect of more open-ended what the attacks could be rather than like Stride or Dread, because to me, Stride is a great introduction if developers aren't familiar with it and say, oh, you have to think about how things could be spoofed or tampered. So that's why you have integrity checking, have an HMAC on your JWT. You can also have about repudiation. That's why it also has a HMAC on it, or it's encrypted, or denial of service, or elevation of privilege. But if you just, to my mind, when you just have Stride and Dread, you kind of can paint yourself in a corner, so to speak, that you might just be focusing on those particular types of attacks and forgetting a little bit of the larger picture of what's the workflow you've built? What's the functionality? How could people think through to say, well, what if I, in this checkout process, what if I apply this coupon code 10 times? Can I, get this for a negative amount and get a charge, a credit to my credit card as I do this, and lots of other types of logical types of attacks that are targeting the functionality. So that's sort of where I lean on this list of threat models.
Yeah,
and that makes sense to me.
Earlier, kind of her approach, right? And she said it's kind of a variation of Stride. I'm used to Octave because Octave was kind of one of the early ones in the traditional asset infrastructure side, right? And a lot of the work we did in vulnerability management, Octave was a very interesting, but I think it has a lot of shortcomings when it comes to AppSec, particularly. I think it's great for endpoint and network type of analysis, but falls down on the application side. I'm also familiar with the NIST model as well. I think the challenge with the NIST model potentially, though, even though I think it covers the right things, is how do you put it into a framework for people to understand, Mike? And I think that's where sometimes people tend to go to Stride or Dread because it's more specific, even though maybe it misses some stuff or oversimplifies certain areas.
You're right about that. It definitely requires, it pushes a lot more burden onto like the AppSec team or the DevSecOps team for their maturity level and how they manage and measure that to compare. One of the things is sort of an anecdote. One of the reasons I love to talk about directory traversals, and I'm making a note because we haven't had a good findings for a while, is it actually as an exercise. I like it. I think it could be a great exercise for threat modeling because you can start with saying, here's a directory traversal vuln. One, you could start with input validation. Cool. Well, why do we have ... anyway? And we can, traverse up and down a path. You can also talk about normalization because you can say, oh, well, we're just stripping any leading ... But what if you put that ... within the middle of that file name? You're still going to get around it. So that's some smart, being clever. That's some ways you can talk about normalization. But then you can also start to talk about file system security and containerization, perhaps, and really isolating this environment because you can say, well, what if we can get out, we do have this file system traversal. Why are we getting into the root of our Linux file system? Why can we get into a execute bin sh for that matter or something else? So that way is there's some good narratives you can build up as an exercise in threat modeling that sort of helps get people thinking about this. And again, admittedly, it's not as easy to do when just say, here's Stride, here's Dread, here is the card game that Microsoft actually put out about this that makes it really easy to educate around threat modeling.
Mm-hmm. Right. And she did talk about, she does use the Microsoft tool in her practice to actually run some of these scenarios. So I thought it was interesting that using the Microsoft tool, not the, because OWASP I think has a tool as well to help with some of these threat models.
Yeah, OWASP has there's Threat Dragon, And there's been a couple others where OWASP has both tried to doing threat modeling as code. Basically, you can annotate your code with kind of here's an assumption when this is true, this should also be true, or if this happens, then this should happen. So sort of kind of an expressive language for it. It definitely can be burdensome to put together, but it can be a great way then to automatically generate, here is the pretty graph of what our code looks like and what we are considering. But I haven't seen it in use. So if any of our listeners out there have been using any of those types of approaches, I'd love to know and learn more about what worked and what was the journey to get that into working. But I guess I will also say is that threat dragging could also use just a lot more attention as a project and investment to help mature that to be better, more easily used.
I thought you were. I'll have to look at threat dragging. I haven't heard of that one. I thought we were going, Microsoft used to also have Protection Poker, which they actually had as a deck they'd give out, I think, at shows and stuff. And I picked up one at RSA from ExtraHop, and it's still in a packing box, so I can't find it around here yet. But they were looking at doing something similar, and I think they were a little let down when I'm like, oh, it's just like Protection Poker. They're like, what's that? And I guess they thought they were the first. But so those ones I like because it gets you off the computer a little bit, right? And actually has you, I hate saying think outside the box, but getting a little bit further away from what the keyboard and the daily coding stuff sometimes helps.
Tabletop exercise.
Yes.
Tabletop exercise, absolutely, and I think that's another reason that moving a little bit outside of just stride and dread also helps trigger some more of the creative thinking about asking pose a question: how would you, developer, attack your own application? In other words, where some of the crusty code is, some of the weaknesses are, some of the areas that are sort of that are in the code that are like, well, we'll do this now and then we'll come back to this and fix it up later. So those are kind of great questions to ask, as well as long as you approach this in a collaborative manner. You could say, what other, in your dependency tree of other microservices or other services your app interacts with, where do you think the attack is going to come from? And that could be just another way of just illuminating both where do developers perceive issues, and are those perceptions of security issues match where you think the actual risk is? And those are just great ways to then build on that conversation. And one of the things I brought another article in here that is privacy in the time of COVID. This one in particular is from Wired, and it speaks to threat modeling. And rather than get into, again, the specifics of building and discussions of contact tracing, I wanted to use that, for example, the tools that Apple and Google have been talking about, and how would you approach them, using them as an exercise as demonstrating threat modeling? Because you could look at this from the perspective of functional requirements, and you could say, well, GPS, for example, doesn't have the granularity of what you would need to see if someone is within 6 feet of each other, or this weird way of measuring distance called the metric system, and make sure they're within 2 meters. So they're looking for Bluetooth and granularity. But then again, you can also have threat models around, what if two people are standing very close but separated by a wall and therefore wouldn't infect each other, but Bluetooth perhaps could reach through there? So that's the way you could talk about the functional threat model. And then, of course, you can get some other threat models in terms of how do you go after people targeting the system and misrepresenting and saying they are infected to try and spread a false positives throughout this. So I think there's some really interesting ways to talk through a very topical scenario, and that might be more or equally interesting, for example, as the directory traversal scenario that I mentioned as a threat model reference.
Well, and there's also the technologies that are in use here, right? Because you're using Bluetooth. There's been a lot of vulnerabilities in the Bluetooth protocol, depending on whether you're using low energy or non-low energy types of Bluetooth, right? So you've got a whole potential class of vulnerabilities here that people aren't used to working with or dealing with that could also tamper information. This is an interesting topic because there are scenarios where the data may never become part of the bigger model, but then it can be how do people really understand what the privacy and security implications are based on these different things. So this is a really interesting one, I think, to threat model because it has such a vast potential impact.
Absolutely. And a lot of this, we talked, I want to say last WWDC, Apple, we talked about Apple's approach to Find My Phone. And they were talking about basically using Bluetooth to beacon with other iPhones in a privacy preserving manner to say, here is the area where we last saw your phone. So this is where we think it may be lost. And that's pretty interesting because if I, the end user, have lost my phone, it's pretty easy for me to understand that decision process of, hey, my phone is lost, I need to do something. But if we talk about exposure to something like COVID or contact tracing in the past 2 weeks, there's also a difference to say, I've been exposed, what should I do? As meaning, do I need to go get tested? Do I need to go to the emergency room now? Do I just need to self-isolate? As well as in the centralization aspect, Apple is just want to make sure that you yourself can find your own phone, and it will basically act as the broker in that privacy preserving way, so it can't peek into the data and just say, cool, somebody lost their phone, here's where it last was, hopefully you can go find it. In this scenario, though, with COVID, we're talking about the CDC, for example. It would actually be a lot more helpful for them to be able to centralize and organize, oh, here is where outbreaks are, or here is where exposures have been. And that's much different in that to them having access to that information is actually has use cases much more so than just Apple purposely not needing to know where you lost your phone. So yeah, you're right that I think there's a lot of interesting ways you could talk through this from without writing any code and just figuring out what should we be doing, what are the trade-offs we're making from that engineering perspective.
Yeah, definitely.
Yeah,
opens a whole can of worms.
A whole can of worms. And go ahead.
It is a really interesting one because as you were just saying, Mike, I think you sort of nailed it, right? This is at its root not a super technical problem. We've done Bluetooth beacons for years. Okay, if you want to encrypt or something else, fine. But I'm going to hand wave that as a detail. But the ability to like see what devices are nearby you and then keep track of that, and I like what they're doing with the short-term tokens. But so you can have a really great conversation around that, lunchtime conversation without like having to worry about the, what language or what are you doing, all those type of things. Where it becomes a little more interesting from an engineering point of view is how do you scale this thing? Like there's I guess Moxie did a not a single tweet, but a thread on, hey, there's more stuff to do here. So it's a really interesting conversation because you can either go fully lightweight, almost product discussion type thing, but also you can get really down into weeds as well.
Yeah, and it pulls in a lot of people, and that was one of the things that I maybe unfortunately we glossed over a little too much. Is that when Rebecca was talking about trying to be like a coordinator of this threat modeling information, so that the lots to share information and really inform different teams. She was rattling off the dev team, obviously, the red team, blue team, but she also mentioned privacy and compliance, and I think legal as well. And quite clearly, there you can apply threat modeling not only to the application security layer, or that lens, but that privacy lens, the compliance lens, the legal lens, as well as the product features. What does the product need to do? Are we introducing to use? I cringe saying this, but user friction. The Silicon Valley speak, or how is this impacting the user experience in a negative manner? And so these are different ways that threat modeling can be really useful. So it does come back to those areas where Stride and Dread, I'll just kind of pick on those again, are great steps and great helpful to focus on that AppSec angle. But you do definitely need to pull out more at a higher view, I guess, looking at those general questions, which can be harder to answer, harder to come up with from that NIST model, or even Octave, for example, that really looking at you from the organization level rather than is looking at a portfolio of apps, if you will, rather than one app. So it's more of just understand what approach you're taking with your threat model and how the framework fits best for what you're trying to do, whether it's a single app, your organization, something else. Cool. Well, I think we possibly have modeled that discussion quite a bit. And I did make my subtle Kraftwerk reference to Das Modell at the very beginning. So hopefully there's somebody out there smiling, in addition to the puns that I snuck through for this week. Matt, John, anything else you want to add for today?
We've covered Kraftwerk. I'm happy.
Excellent. Well, definitely want to thank you for suffering through a handful of puns that I snuck in. So thank you, Matt. Thank you, John. Thanks everybody for listening, and thank you for joining us this week. We're going to see you again next week on Application Security Weekly.